Hey everyone, Mr. Houck here. In today's video, we're going to be going through an entire version of the Unit 6 quiz. Now for this quiz, I'm going to be showing all the work. The only things I'm going to be using are a Desmos graphing calculator on my laptop, and I have another page with a unit circle. If I need to look up formulas as I'm going through the quiz, I'll do that as I need to. Okay, so I'm going to go through the quiz, show you how the problem should have been done, just because those quiz grades were a little low. So make sure that you pay attention, pause the video when you need to, play it back when you need to, and we'll go ahead and go through this version of the quiz. Okay. So many of the problems on the quiz were problems like this, where you had work and you need to verify if the work was either correct or if there was a mistake somewhere. So here in number one, this is number one for me. The below work was done to solve sine of 35 pi over 36, cosine 13 pi over 18 minus cosine 35 pi over 36 sine 13 pi over 18. We want to know if the work was done correctly or where the first mistake was. So notice all this right here was copied over correctly. It's in the same order. You got the minus sign in the middle. So line 0 should be fine. Looking at this, we have sine, cosine, minus cosine, sine. And that is following a sine subtraction formula. If we look at the sine subtraction formula, it goes like this. Sine alpha cosine beta minus cosine alpha sine beta. So the subtraction formula for sine is being used perfectly, where 35 pi over 36 is alpha and 13 pi over 18 is beta. So all that looks fine. So then going from step 1 to step 2, or line 1 to line 2 rather, this student is saying sine of 35 pi over 36 minus 13 pi over 18. They're saying this part, 35 pi over 36 minus 13 pi over 18, is 9 pi over 36. And this is also going to be correct, because if we think about 13 pi over 18, this is really, notice we want a denominator of 36. We need a common denominator to subtract. To turn the 18 into a 36, we need to double the 18. So we need to double the 18 and the 13, the numerator and the denominator. So this would really be 26 over 36. Well, 35 pi minus 26 pi is 9 pi, and we keep the common denominator of 36. So from step 1, or line 1 to line 2, that looks correct. Notice that 9 over 36 reduces to 1/4. So this step is correct. And then sine of pi over 4, well, if we look at our unit circle, here's pi over 4. Sine is the y value. That's square root of 2 over 2. That's also correct. So all the work is done correctly. Okay, so that's how you want to approach those problems. Notice we didn't redo all the work ourselves. We just verified the lines, made sure they were correct, or if there was a mistake, that's what we would have picked as our answer, is the line that the first mistake took place in. All right, so let's do another one like that. Here, we have the work is done to solve this thing right here, tangent pi over 12 plus tangent 5 pi over 12 over 1 minus tangent pi over 12 tangent 5 pi over 12. So same deal. Let's start checking through the work. First things first, here's the problem. It looks to me like it was copied over correctly, so line 0 should be fine. If we look at the format, it goes tangent plus tangent. And if we think about the tangent formulas, if there is an addition in the numerator, then it is an addition formula for tangent. And we can see pretty clearly here that pi over 12 is going to be alpha, and 5 pi over 12 is going to be beta. So alpha and beta, pi over 12, 5 pi over 12, those are put in the correct places for the formula. So line 1 looks fine. Moving from line 1 to line 2, pi over 12 plus 5 pi over 12 is 6 pi over 12, so that's correct. 6 pi over 12 is just 1/2 pi, so that's good. And then let's go and calculate the tangent of pi over 2. Well, here's pi over 2. Tangent is actually undefined at pi over 2. And line 4 is saying that the tangent of pi over 2 is 0, which is incorrect. The tangent of pi over 2 is undefined, so line 4 is where our mistake is. Okay, so we select line 4 as the correct answer, because that's where the first mistake took place. All right, number 3, another did they do it correctly type of problem. So let's find out if they did it correctly or not. We want to solve cosine of 19 pi over 12. Well, they copied the problem down correctly, so line 0 looks good to me. This student is saying that 19 pi over 12 is 7 pi over 4 minus pi over 6. And let's see if that's correct here. So 7 pi over 4, if we convert that, that's really 21 pi over 12. Okay, just multiply top and bottom there by 3. And pi over 6 is really 2 pi over 12. And 21 pi over 12 minus 2 pi over 12 is 19 pi over 12, so line 1, correct. And this is a cosine subtraction formula. And we know that cosine is the one that's a little strange. Cosine, if it's a subtraction formula, actually has a plus sign that goes in the middle there when you continue with the formula. So it's looking like everything here is checking out from line 1 to line 2. I remember that the cosine formula goes cosine alpha, cosine beta, plus sine alpha, sine beta. Remember the 7 pi over 4 and the pi over 6, those are really the alpha and beta here. I just wrote over them to show you that they equal 19 pi over 12 when you subtract them. So the 7 pi over 4 and the cosine, or in the pi over 6, those are put in the correct places. It looks like the formula is being followed pretty well here. And you know, just as reference, I'll go ahead and write it down. Cosine subtraction formula, cosine alpha, cosine beta, plus sine alpha, sine beta. So again, cosine, that weird one, subtraction formula has a plus sign in the middle. Let's make sure that they carried over all these pieces correctly. So let's go and calculate cosine 7 pi over 4. Here's, that's not 7 pi over 4, where is it? There it is. 7 pi over 4. Cosine is square root of 2 over 2. That looks good. Let's go do cosine of pi over 6. Square root of 3 over 2. That looks good. Sine of 7 pi over 4. Negative square root of 2 over 2. That looks good. And sine of pi over 6. 1/2. That looks good. Excellent. So everything looking good so far. Let's start multiplying now. Square root of 2 times square root of 3 is square root of 6. And they put 6 without the square root. That means line 4 is our mistake. We don't even need to continue over here. We already know they goofed up because that should be a square root of 6. So, and there's our correct answer, line 4. All right, problem number 4. Another did they do it correctly or not kind of problem. So we want to see if their work was correct to solve sine of 5 pi over 3. And this student is saying that sine of 5 pi over 3, well, first off, they copied it correctly. So line 0, good. They're saying that 5 pi over 3 is 2 times 5 pi over 6. Well, let's just double check real quick. 2 times 5 pi over 6 would be 10 pi over 6, because you can really think of this 2 as a 2 over 1. So the 2 is multiplying to the 5 pi to make 10 pi, then over 6. And 10 over 6 is 5/3. So, yeah, looks good to me. 5 pi over 3. So line 1 looks like it checks out. Continuing with the formula here, notice this is a double angle for sine. And sine of a double angle sine of 2 theta, is going to be 2 sine theta cosine theta. And theta, of course, in this case, theta is going to be this 5 pi over 6. That's the angle that's getting doubled, right? So did they apply the formula correctly? Well, it looks pretty good to me. They've got the 2 on the outside. They didn't forget that. And theta is that 5 pi over 6, the angle that's getting doubled. Well, they did sine of theta, cosine of theta. Line 2 looks good. Let's make sure that sine of 5 pi over 6 is negative 1/2. And let's check to see if cosine of 5 pi over 6 is square root of 3 over 2. So 5 pi over 6, here we go. Sine of 5 pi over 6, the y value is 1/2. So that, they put negative 1/2. And again, let's just verify. There's 5 pi over 6. Sine is the y value. Sine should be a positive 1/2. They have negative 1/2. Line 3 is the mistake, and that's our correct answer right there. That's where the mistake happens. All right, moving along nicely. So number 5, another, did they do the work correctly? And notice that this is where I'm saving a lot of my time in this quiz. We're just verifying steps. We're not redoing the entire problem from scratch. We're verifying their steps. So the work was done to solve tangent of 300 degrees. This student is saying, well, first off, they copied it over correctly. So line 0 looks good. They're saying that 300 degrees is 2 times 150, which is correct. 2 times 150 is 300. And then they're saying that this is the formula. So let's just go ahead and double check. Let's remind ourselves of what the double angle formula for tangent is. Tangent of 2 theta, so we're doubling the angle theta, is equal to 2 tangent theta over 1 minus tangent theta, or tangent squared of theta. Okay, that's our double angle formula. And we can see that theta, the angle that's being doubled, is 150. So I'll go ahead and label that as theta. And let's see if they applied it correctly. Well, 2 tangent theta, 2 tangent 150, 1 minus tangent squared, and they put a plus sign right here. So line 2 is where they goofed up. That's where their mistake is. So our answer there would be line 2. All right. So there's half the quiz. Half the quiz was, verifying steps. And notice you got a good variety of problems. You have some double angle formulas in number 4 and number 5. You had some, just general solving with sum and difference formulas with number 2 and number 3. And also number 1. So 1, 2, and 3, some sum and difference formulas. 4 and 5, some double angle formulas, verifying whether their work was correct or not. So that's about half the quiz. Then the quiz, the other half of the quiz is more kind of calculating on your own. So number 6 here, find the exact value of tangent of negative 31 pi over 12. So negative 31 pi over 12 here. First things first, negative 31 pi over 12 is a pretty large negative angle. And what I'm going to do first is I'm going to get negative 31 pi over 12 into a more reasonable angle, one that's going to be within 0 and 2 pi, or 0 and 360 degrees. So let's do that. And remember from first semester, we talked about coterminal angles, or getting an angle onto the unit circle somewhere by adding or subtracting 2 pi, or 360 degrees. Well, since this is in radians, I'm going to go ahead and add 2 pi. And 2 pi in this case would be 24 pi over 12, by the way. I'm writing it in a way so that we have a common denominator. Okay, so 24 pi over 12, we add that together. Negative 31 pi over 12 plus 24 pi over 12, that's going to be negative 7 pi over 12. And I think that's going to be a much more manageable angle to try to take the tangent of. So let's start by trying to take that tangent. Tangent, negative 7 pi over 12. Well, it's a negative 7 pi over 12, so I'm going to think about subtraction. And let's go over to our unit circle here. And here's what I'm thinking. Pi over 6, which is 2 pi over 12, minus 3 pi over 4, which is 9 pi over 12. Because 2 pi over 12 minus 9 pi over 12 is negative 7 pi over 12. So again, that's going to be pi over 6 minus 3 pi over 4. Okay, this is going to be your alpha, this is going to be your beta. Notice that this is a tangent subtraction. So when we think about tangent subtraction, it goes like this. Tangent alpha minus tangent beta over 1 plus tangent alpha times tangent beta. And of course, alpha is pi over 6, beta is 3 pi over 4. So let's replace those pieces. Tangent, let's just go ahead and write it all out. Tangent pi over 6 minus tangent 3 pi over 4 over 1 plus tangent pi over 6 times tangent 3 pi over 4. Let's calculate the stuff here. Tangent of pi over 6 is square root of 3 over 3. Tangent of 3 pi over 4, there's 3 pi over 4, tangent's going to be negative 1. So minus negative 1. Get that double negative there, I don't want to forget that. Over 1 plus, but we already know tangent of pi over 6 is square root of 3 over 3 times negative 1. All right, so here's where these kind of these algebraic steps come in, the ones that can be a pain sometimes. So double negative up top, this can be square root of 3 over 3 plus 1. In the bottom, we're going to get 1 minus square root of 3 over 3 because you're multiplying times negative 1. I'm going to go ahead and turn these 1s into 3 over 3s. So this gives us square root of 3 plus 3 over 3 over 3 minus square root of 3 over 3. We know those 3's will cancel. So now we have square root of 3 plus 3 over 3 minus square root of 3. That square root in the denominator, we're going to go ahead and multiply by the conjugate, which would be 3 plus square root of 3. Notice we're just taking the denominator, changing that sign in the middle. Well, let's FOIL here. Root 3 times 3, that's 3 root 3. Root 3 times root 3, that's plus 3. 3 times 3, that's plus 9. And 3 times root 3, that's plus 3 root 3 again. In the denominator, 3 times 3, FOILing again, that's 9. 3 times root 3, that's 3 root 3. Negative root 3 times 3, that's negative 3 root 3. And negative root 3 times root 3, that's going to be negative 3. Notice square roots and denominator cancel, like they always should when you multiply by the conjugate. Up top, 3 plus 9 is 12. 3 root 3 and 3 root 3 is 6 root 3. In the denominator, 9 minus 3, that's 6. And let's go ahead and separate the fraction just so we can see things cancel out really nicely here. 12 over 6, that's going to be 2. 6 and 6 reduced to 1, so we just get root 3. So the answer should be 2 plus root 3, which is right there. Okay, so a little bit of a pain because there's a lot of algebraic work there, but you know, we've done several examples in class in the notes and in the Socratic assignments, so definitely not out of the realm of definitely not an crazy hard problem. All right, number 7 here. Here we get our first taste of a triangle problem where we have to make double triangles to solve some problems here. So first triangle, sine of alpha is 1/2, where alpha is between 0 and pi over 2. This, by the way, just means that alpha is in quadrant 1. So let's go ahead and do that. So let's make our quadrant 1. Nothing fancy. And notice this says sine of alpha is 1/2. Well, sine is opposite over adjacent. Here's alpha, opposite's 1. It's not opposite over adjacent, sorry, opposite over hypotenuse. Opposite is 1, hypotenuse is 2. Let's do Pythagorean's theorem real quick. The missing side I'll call x. So x squared plus 1 squared equals 2 squared. So x squared plus 1 equals 4. X squared equals 3. So x equals square root of 3. So this will be square root of 3. And it's positive, because we're in the first quadrant, that's a positive side of the x-axis. Okay, let's go ahead and do the other triangle while we're at it. Cosine of b, I just realized this says a, not alpha. We'll just pretend that's an a. Cosine of b is 2/3, where b is between 0 and pi over 2. So b is also in quadrant 1, which is pretty nice for us. Let's go ahead and do another quadrant 1 triangle. All right, here's b. So this time it says cosine of b is 2/3. Cosine's adjacent over hypotenuse. So adjacent is 2. That's this side. Hypotenuse is 3. let's do Pythagorean's theorem again. X squared plus 2 squared equals 3 squared. X squared plus 4 equals 9. Subtract the 4. X squared equals 5. Take the square root. X equals square root of 5. And again, positive square root of 5 because we're on the positive side of the y-axis. Okay? And what we are trying to find with these triangles is the sine of A minus B. Well, if we do the sine subtraction formula real quick, sine of A minus B is going to be equal to sine A cosine B. Almost wrote beta there, so used to that. Sine A cosine B minus cosine A sine B. And let's put in some pieces here. So sine of A, well, we already know sine of A is 1/2. We were given that. So sine of A is 1/2. Cosine of B, we are given that as well. That's 2/3. Cosine A, well, here's, remember this is really supposed to be an A. I'll go and replace that with an A. Cosine of A is going to be adjacent over hypotenuse. That's square root of 3 over 2. And sine of B, opposite of hypotenuse, that's square root of 5 over 3. All right, and now we just do this calculation real quick. 1/2 times 2/3, that's going to be 2/6. Minus root 3 times root 5, that's root 15 over 6 as well. Common denominator of 6, we can just subtract the numerators together, all over 6. 2 minus root 15 over 6, which is this answer right here. Okay, so really not that bad. Even a double triangle problem like that, the calculations involved really weren't that difficult for that problem. All right, 3 more to go. Number 8, another double triangle problem. Sine of A, almost said alpha again. Sine of A is 3/5, where A is between pi over 2 and pi. Let's do that. Let's draw that triangle real quick. So pi over 2 and pi, that means you're in quadrant 2. And if you can't tell that, if you go to your unit circle, there's pi over 2, there's pi. Everything in between is quadrant 2. So let's draw ourselves a quadrant 2. All right, here's angle A. We're told that sine of A is 3/5. So opposite of our hypotenuse, opposite, that's 3, hypotenuse is 5. Notice we're trying to find this leg next. We're going to need that leg for our calculations. But in my mind, I'm already thinking this is the negative side of the x-axis. So I already know this has to be a negative number. Let me put the negative there just so I don't forget. Let's go ahead and do a calculation there. So 3 squared plus whatever that side is, we'll call it x. X squared equals 5 squared. 3 squared is 9, 5 squared is 25. Subtract the 9 from both sides. That's going to give us 16. Square root of 16 is 4. So this is a negative 4. By the way, 3, 4, and 5, that's a Pythagorean triple. That's a good one to memorize. So we know that, but again, we know this is a negative 4 because it's on the negative side of the x-axis. And by the way, just for documentation purposes, let's go ahead and put this as quadrant 2. All right, so now we're going to look at B. Cosine of B is 24 over 25, and B is between 3 pi over 2 and 2 pi. That is quadrant 4. Okay, so let's go ahead and make us a quadrant 4 triangle. And there's angle B coming out of the origin. Cosine of B is 24 over 25. Cosine is adjacent over hypotenuse, so here's the adjacent, 24. Hypotenuse, 25. Notice that, again, I'm going to need to find this side right here, and I'm going to go ahead and put a negative because I already know it's on the negative side of the y-axis. So just little things that I do to make sure I don't make simple but costly mistakes in the end. So let's go ahead and find that piece. I'm going to call it x, the piece that we're looking for. X squared plus 24 squared equals 25 squared. Let's see, 24 squared. I don't have that memorized. Let me turn to my calculator. Should have that memorized though. 576. 25 squared should be 625. Just double check. Yep, 625. Let's subtract those. So 625 minus 576, we get 49. X squared equals 49, which means x equals 7. Another Pythagorean triple, by the way. 7, 24, hypotenuse 25, another Pythagorean triple. But again, this side is going to be a -7 because we're on the negative side of the y-axis. So this time we want to calculate cosine of a plus b. So cosine a plus b equals cosine a cosine b minus sine a sine b. Keep in mind that cosine is kind of a weird one. You got the plus sign here in the middle. You really get a minus sign when you continue with the formula. All right, so cosine a times cosine b. Cosine of a is going to be -4/5. Cosine b, we already knew, was 24/25. Sine a, we already knew, was 3/5. And sine b is -7, -7/25. Almost put -7/24. Had to catch myself there. -7/25. All right, and now let's calculate. And again, I'm going to pull out the calculator here. -4 times 24, I think that's 96. Let me just double check. Yep, so -96 because of the negative. So -96 over 125 because that's 5 times 25. Plus, I'm putting a plus here because I can already see the double negative. So let's see, 3 times 7, that's going to be 21. 5 times 125 on the bottom, another 125. -96 plus 21, that's going to be -75. And -75 over 125. Both those numbers are divisible by 3, so this is really going to be, actually not by 3, by 25. 75 can be divided by 25 3 times. 125 is divided by 25 5 times, so this is really -3/5, which is our correct answer right there. Okay, so almost done. 2 more problems to go, one of them being the free response. Here's another triangle setup problem. This time it's going to be a double angle, sine of 2 theta. But here, sine of theta is -7/9, and theta is between pi and 3 pi over 2. Between pi and 3 pi over 2, by the way, is quadrant 3. Okay, so let's set up a quadrant 3 triangle. And here's theta coming out from the origin. So sine is opposite over hypotenuse. -7 for the opposite. Hypotenuse is 9. Notice I know this this has to be negative because I'm on the negative side of the y-axis right here. Let's go ahead and find the this leg. We're going to need it for the calculation anyway. So -7 squared plus x squared equals 9 squared. 7 squared, that's going to be 49. 9 squared, that's 81. Let's go ahead and do 81 minus 49. It's going to be 32. And let's take the square root of both sides. So x is square root of 32, which, let's think about 32 real quick. 32 is 16 times 2, and the square root of 16 is 4, so this is really 4√2. Okay, now notice I'm going to make it a -4√2 because we're on the negative side of the x-axis. Okay, so we want to calculate sine of 2 theta. Well, if we just follow our sine double angle formula, this is going to give us 2 sine theta cosine theta. And let's see here, let's see, sine of theta, we already knew was -7/9, we already had that calculated. Cosine theta, that's going to be -4√2 over 9, adjacent over hypotenuse. And if we go through and calculate here, 2 times -7 times -4, that's going to be, what, let's see, 56 root 2. Just double check that in the calculator, make sure I don't mess up that calculation. Yeah, 56. Also note it's positive, negative times a negative. Denominator, 9 times 9, that's 81, of course. And I don't think that's going to reduce. Yeah, there we go. Here's our answer, 56 root 2 over 81. So all that work was done correctly. All right. So one more problem, and that's going to be our free response problem. So this free response problem says given the tangent of theta is negative root 5 over 3, and that theta is between pi over 2 and pi, which, by the way, between pi over 2 and pi, that's quadrant 2. We want to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. And one more note about free response. Keep in mind, we talked about this in class. Your free response is worth the most points. On this quiz specifically, it was 28 points. So really make sure that you're getting the free response done. So quadrant 2, let's go ahead and set up our triangle. We have this nice little coordinate axis right here. So here's theta coming out from the origin. We're told that the tangent of theta is negative square root of 5 over 3. So tangent, that's opposite over adjacent. Okay, and we're going to be calculating, with all these calculations, we're going to need to go ahead and find the hypotenuse. So let's go ahead and find the hypotenuse. So we get negative square root of 5 squared plus 3 squared equals c squared, because we're calculating for the hypotenuse. Negative square root of 5 squared is going to be 5. 3 squared is 9. That gives us 14. And we take the square root of both sides, so hypotenuse is going to be square root of 14. All right, so let's go through and do these calculations here. Sine of 2 theta is up first. And we know sine of 2 theta is 2 sine theta cosine theta. Well, let's actually go ahead and let's do a few things real quick just to make all the calculations we're going to have to do a little smoother. Let's go ahead and do sine of theta, cosine of theta, and tangent of theta, because we're going to need them anyway. Let's see, sine opposite over hypotenuse, negative root 5 over root 14. And let's, by the way, I almost made a mistake here. That should have been a positive root 5. This should be the negative 3. So I almost messed up the signs there, something that I caught just now looking at it, because again, we're on the positive side of the y-axis. This should be positive. Negative side of the x-axis, this should be the negative. So glad I caught that mistake before it actually cost us anything. So let's go ahead and, again, sine of theta, opposite over hypotenuse, so square root of 5 over square root of 14. Let's go multiply top and bottom by root 14 over root 14, because we don't like that root 14 in the denominator. And 5 times 14, that should be 70. Let me just double check. Yep. So this is going to be square root of 70 over 14. So we'll be using that for our sine theta. Cosine theta is going to be negative 3 over root 14. Okay. And let's see, again, we're going to go ahead and multiply top and bottom by square root of 14 over square root of 14. And if we do that, we're going to get negative 3 root 14 over 14. That's going to be what we use for our cosine of thetas. And tangent, we already know, is negative root 5 over 3. No need to reinvent the wheel there. Okay, so now that we've got that established, let's go ahead and start calculating. So we're calculating sine of 2 theta, which is 2 sine theta cosine theta. That's 2 times root 70 over 14. And then cosine theta is negative 3 root 14 over 14. Okay. And let's see, multiplying this stuff out here. 2 times negative 3, that's negative 6. Then we have root 70 times root 14. So the 70 and the 14 are going to go down here together. And then over 14 times 14, 14 squared. That's going to be, let me go and calculate that as well. It's 196. And the thing about 70 times 14, well, one thing we already know about 70, we know that 70 is 5 times 14 over 196. And we know that, if you have a 14 times a 14 here, that's going to get pulled to the outside, so negative 6 times 14 root 5 over 196. And then we'll go ahead and use a calculator or something. Let's simplify this. 6 times 14 over 196. That is 3 root 5 over 7. Okay, and let me just double check my key real quick just to make sure that that is correct. But I'm pretty sure that's correct. That looks pretty good to me. Just one more second, loading my key real quick. Yep, that's what I got on my key. So perfectly good. All right, now let's do cosine of 2 theta. So cosine 2 theta. Well, cosine of 2 theta, that's going to be cosine squared of theta minus sine squared of theta. That's the double angle formula we have for cosine. Cosine squared, that's going to be negative 3 root 14 over 14 squared minus root 70 over 14 squared. And let's start doing some calculations here. So negative 3 root 14 squared, well, negative 3 and negative 3, that's going to be 9. And then we're going to have 9 times 14 because you're also squaring the square root of 14. And then 14 times 14 on the bottom, that's going to give us that 196. Okay. Root 70 squared is just going to be 70 over 196. Let's see, 9 times 14, let's use a calculator for that. That's 126. So 126 minus 70 over 196. That is going to be 56. And 56 divided by 196 is 2/7. And again, let me double check with my key real quick, and yes, that is correct. Awesome. So one more left to go. We need to calculate tangent of 2 theta, the one that has the potential to be the most annoying one, but we'll see. So tangent of 2 theta. We know that tangent double angle formula is going to be 2 tangent theta over 1 minus tangent squared. That's 2. Let's see, tangent of theta is negative root 5 over 3. 1 minus negative root 5 over 3 squared. Okay. Let's see, that's going to be negative 2 root 5 over 3. Just multiplying that by 2 over negative root 5 over 3 squared. So that's negative root 5. Oh, that was terrible. Negative root 5 over 3 times itself. That's going to be positive 5 over 9. So 1 minus 5/9. All right, continuing to simplify, we'll keep the top here. Negative 2 root 5 over 3. On the bottom, let's go ahead and take this 1. Let's make it a 9 over 9. Get a common denominator. 9 minus 5, we get 4, so this is really 4/9. And we'll do keep change flip. Negative 2 root 5 over 3 times Then flip the bottom, 9/4. Let's do some reducing here. 9 and 3, 2 and 1. So this is really -3/5/2, which is the correct answer. Just double checked with my key. All right, well, there's the quiz. So, as you can tell, some of the calculations, some of the calculations can be a little bit difficult, but that's just the nature of these problems, especially when you get problems that deal with square roots. But here's all the, the 10 different problems, work included. You watched me work them from scratch, so it's not like I, had all the answers already written and everything. So this was done in real time. I referenced formulas as I needed them, referenced the unit circle as I needed to, used the calculator as I was doing calculations, and you can see that I got this done within the time limit perfectly fine. Okay, and I was explaining the problems as I was doing them. If I wasn't explaining the problems as I was doing them, I would have done it even faster. So definitely doable within a reasonable time limit. You just got to make sure that you have all your formulas handy, you got your calculator handy, get your unit circle with you, and that you just generally know what you're doing when you're working through these problems. You don't want to have to be stopping to look at the notes, figure out what you're doing, how to solve the problems. That's where the practice comes in.